Hello friends, in this video we are going to discuss sign convention in mirrors. Till now we have discussed the formation of image in plane mirror, different terms related with spherical mirrors, then formation of image in concave and convex mirrors. Sign convention. As like in mathematics, you have already known about the, suppose this is x and y axis, this direction is origin, this is positive, towards left is taken as negative, upward positive, this downward negative. That means along this axis positive and this is negative. Similarly, imagine this is a concave mirror and imagine this is pole of the mirror, this is concave mirror. So, or this is convex mirror, again this is principal axis, left this is pole. Compare. If you compare this with this Cartesian coordinate in mathematics, easily you can understand. The first is all the distances are measured from pole of the mirror. All the distances are measured from the pole of the mirror. So all the distance are measured from the pole of the mirror, first sign convention. Second is the distance is measured towards right of the principal axis taken as positive and towards left taken as negative. Similarly, in case of this convex mirror, this distance is taken as positive, this is taken as negative. So second option is, second sign convention is the distance is measured along towards right of the pole is taken as positive and towards left taken as negative. Third is distance is measured perpendicularly above the principal axis taken as positive and below the principal axis taken as negative. The distance is measured perpendicularly above the principal axis taken as positive and below the principal axis taken as negative. Okay. Now on the basis of this, now try to understand in case of a concave mirror, as the center of curvature lies here, focus lies here, this distance is known as focal length. So it must be negative. Look at here, it towards left. Similarly, this distance is radius of curvature, the distance between center of curvature and pole. So it is also negative. That means in case of a concave mirror, the focal length is negative. Come to convex mirror. This is a convex mirror. Focus, center of curvature, pole. Look at here, it is towards right. So this distance is taken, focus, focal length is taken as positive towards right. Similarly, the distance of separation, this distance, this is distance of separation between P and C is taken as radius of curvature, it is also positive. So, in concave mirror, focal length negative, in convex mirror, focal length positive. Remember this. Okay, now, mirror formula. What is mirror formula? Mirror formula is 1 by V plus 1 by U is equal to 1 by F. This is the mirror formula. Now what are U, V and F? U is object distance, V is image distance, F is focal length. Object distance is the distance of separation between the object and the pole of the mirror. Image distance, distance of separation between image and pole of the mirror. And focal length is the distance of separation between focus and pole. Okay, derivation is not in syllabus. Then magnification. What is magnification? Magnification is the ratio of height of the image to the height of the object. Okay, and it is also equal to minus v by u. You have to remember magnification is minus v by u. It has no unit because it is simple ratio. It has no unit. So what does magnification represent? Magnification represent how many times the image is greater than the size of the object. That means how magnified the image is. कितना बड़ा image है, बड़ा है या छोटा है या semi image है, it can be obtained from the magnification. So in magnification there are two things. One is example. Look at here. Example. Suppose magnification is equal to plus 2. Another is magnification is equal to minus 2. What are the difference between them? Here the plus sign indicate the image is virtual and erect, and the minus sign indicate the image is real and inverted. The plus sign represent virtual and erect, minus sign indicate it is real and inverted. And here what does 2 represent? 2 represents, in this case also this case, in both the cases, 2 represents that image is 2 times magnified than the object. Image is 2 times magnified, means look at here, if I say this is equal to 2, suppose plus 2, it means obviously hi is greater than h0 by 2. That means it is 2 times greater. Height of the image is 2 times greater than the height of the object. That's why here 2 represents image is 2 times magnified. Okay. In case of plane mirror, what is the magnification in case of a plane mirror? You know, for a plane mirror, you know, both height of the object and images are equal. As both height of the object and image are equal, so we can say magnification is equal to 1 plus 1. What does plus represent here? Plus represents it is virtual and erect, and 1 represents it is of same size. Okay? Now, how can you solve the problem based upon mirror formula? Remember, how can we solve problem based upon mirror formula? देखिए, to solve this, you remember, generally object is to the, always we take the object in the left side of the mirror. That means object is in front of the mirror and the light ray pass from left to right, generally. Okay, so for generally object distance is negative. Okay, in some cases it is positive, but it is not in syllabus. So object distance is negative. Generally. And second thing, focal length negative for concave mirror. And focal length positive for convex mirror. Okay. Then, now solve the example 10 point. Example 10.1. What is the question? The question is like this. A convex mirror used for rear view on an automobile has a radius of curvature 3 meter. If a bus is located at 5 meters from the mirror, find the position, nature and size of the image. Okay? At least read the question 2 times. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from the mirror, find the position, nature and size of the image. This is based upon what? The problem is based upon convex mirror. So I must note down that it is a convex mirror. And what is given? Radius of curvature 3 meter. Radius of curvature is 3 meter. Remember, this formula, the mirror formula is only useful only when you have taken the proper sign convention. It is applicable with proper sign convention. So you have to write with proper sign convention. A convex mirror, radius of curvature is 3. So in case of convex, so radius, this is center of curvature pole, it must be positive. So what is focal length? Radius of curvature by 2, 3 by 2, 1.5 meter. Bus is located at 5 meter. Here, bus is the object. It is located at a 5 meter distance. That means the distance between the object and the mirror is 5 meter. So which is U. But it must be minus 5 meter. Minus. Why minus? Because it is in front of the mirror. By sign convention, it must be negative. What you have to find? You have to find position, nature and size of the image. The first position means image distance. Nature and size of the image, it can be obtained from the magnification. So we have to find 2 things. One is V, another is M. What is mirror formula? By mirror formula, you can write V1 by V plus 1 by U is equal to 1 by F. V, you have to find U minus 5, F 1.5. Okay? Implies 1 by V is equal to 1 by 1.5 plus 1 by 5. It can be simply converted into what? 10 by 15 plus 1 by 5, 15 LCM, 10 plus 2, 12 by 15. Fifteen, 5, 3. The 13 by 15. So V is equal to 15 by 13 meter, 1.1 meter. Okay? So the image distance is 1.1 meter. Look at here. You should have to verify. How? It is not, don't write in the answer sheet. V is 1.1. In case of a convex mirror, object is 5 meter distance. And you know, whatever may be the position of the image, except at infinity, always the image is formed in between P and F. So look at here, its focal length is 1.5 and it is obtained 1.1. So 1.5 मान 1.1 मतलब बीच में आ जाएगा. That's why it is correct. So this is position. Now you have to find the nature. So let us find magnification. Magnification is equal to minus V by U. What is it? What is V? V is 15 by 13 divided by U minus 5. It is equal to 15 by 13 into minus 1 by 5 minus n is there. That's why it is 3 by 13. So magnification is equal to 0.0.3. It has no unit. So look at here, magnification is positive and it is less than 1. Less than 1. That's why, so what is the position of the image? Position is at a distance of 1.1 meter behind the mirror. What is the nature? It is virtual and erect because magnification is positive. And what is size? It is diminished, very small, smaller than the object. So position is at a distance of 1.1 meter behind the mirror. Nature is virtual and erect, and it is smaller than the object. Okay? So this is problem based upon mirror formula. Let us take another problem. Second question, suppose question is like this: where should an object be placed to get 3 times magnified image on a screen by a concave mirror of focal length 12 centimeter. Question is, where should an object be placed? Where should an object be placed means you have to find the object distance. Where should an object be placed? So you have to find object distance. To get 3 times magnified image, magnification is equal to 3. But here, plus 3 or minus 3. Look at here, the image is formed on a screen. As it is formed on a screen means it is real and inverted, so it must be minus 3. Concave mirror whose focal length is 12 centimeter. F is equal to how much? What? Minus 12, because in case of concave mirror, the focal length is minus 12. So here only F is given, neither U nor V. The mirror formula is 1 by V plus 1 by U equal to 1 by F. There are 2 unknown factors, one is U, another is V. So first of all you have to relate them so that we can eliminate one unknown variable. Magnification is equal to minus V by U, which is minus 3. Minus minus cancel, so V is equal to 3U. This is one relation which can be used. What is mirror formula? Mirror formula is 1 by V plus 1 by U is equal to 1 by F. V is 3U plus 1 by U is equal to 1 by minus 12. Implies 3U 1 plus 3 equal to minus 1 by 12. So this is minus 3U is equal to 48, implies U is equal to minus 16 centimeter. So object should be placed at a distance of 16 centimeter in front of the concave mirror. Let us verify it. This is a concave mirror. What is its radius of curvature? Focal length 12 means center of curvature is as 24. This is 24 because it is 12. Where the object is placed according to the answer? 16. देखिए, when object 16 means it is placed in between C and F. So image must be magnified and real and inverted. It is found beyond C. Beyond C. So finally what should be written? Where should an object be placed? Object must be placed at a distance of 16 centimeter in front of the mirror. Okay, so in this way we can use the mirror formula to solve the problem based upon this, and we can use the formula of magnification to know about the nature of the image form. Thank you.